Hello everyone, at this part we're going to introduce the site survey preparations. And first is about the purpose. How do we determine the number of required APs and AP models in WLAN projects? How to prepare the test solutions and test report for customers? What is the base for accurately implementing design solutions? Here are the questions we are facing. And to solve these problems or to answer these questions, we can find the result from the site survey. So here you can find the purpose of site survey. First is to provide accurate base for device selection. Based on the result of site survey, we can determine the device model and the quantity. For example, we can figure out how many users or how many STAs inside the coverage. And based on the numbers, we can determine how many APs we need, right? Except that providing accurate base for the design of technical solutions. For example, provide the base for the design of an appropriate network structure and technical solutions. We can determine we will use in-path mode, off-path mode, or we will use centralized forwarding or local forwarding, and so on. And the next is providing accurate base for project implementation. Determine installation locations of devices to provide a base for later project implementation. Especially for this kind of wireless projects, it's very important to decide where to implement the APs, because in this way we can prevent the interference and can improve the performance of the network. Okay, after knowing the purpose of the site survey, then let's see the process of it. Site survey is an indispensable part of WLAN networking. It directly determines the feasibility and the actual performance of a networking solution, and also provides the original reference for later solution design and project implementation. The whole process is divided into 4 steps. The first step is collect and analyze customer requirements. Because after knowing the requirements of the customer, we can design a suitable network for them, right? And second step, test or demonstrate the functions and performance of WLAN devices. And during the test, if we find some points that cannot satisfy the customer's requirements, we can communicate with them and maybe find some suggestions from them. And actually, the third step can be concurrently executed with the second step. Conduct a survey for a WLAN project. And the last step is design a WLAN solution. And as you can see, this page, at this step, here are some key points. For example, at the second step, we should test the device selection, test the plan preparation, test the environment requirements, or conduct an on-site test and demonstration. And the third step, we should think about the actual signal coverage effect, the AP selection, device selection for the antenna feeder system, and installation deployment methods. And during the last step, we should think about the WLAN network architecture, the topology design, IP address planning, channel planning, and some technical points. Okay, this is about the site survey process. And next, we're going to introduce some tools can help us collect the information during the on-site survey. Okay, firstly, obtain and get familiar with the coverage area plans. Firstly, we can request the customers to provide floor plans for the indoor projects. While if it's an outdoor project, we can use Google Earth or some other maps, right, to master the coverage area plan. Okay, and except that we should learn about the customer's access requirements preliminarily. For example, the access rate requirements, right? The type of services on the customer's network, and even the type of wireless STAs that they will use. Is there, for example, most of the STAs are laptops, mobile phones, or sometimes there could be some uh, maybe televisions or printers and so on. Next, learn about the customer's existing network status preliminary. If the wireless network is built based on the existing network, so we should get familiar with existing network status. For example, the applications of customers' existing networks and the running status of the existing network. Okay, and next, obtain the information about the project context. Obtain the information about project context, including the telephone number, the email address, MSN, WeChat, and maybe some others. Right? Okay, this is about the information collection and analyze. And next, we're going to prepare some tools for the site survey. Here in this figure, you can see some of the tools we need. For example, wireless STAs. It could be a laptop. It could be a wireless network adapter. It could be a mobile, right? And except that, we should prepare AP or AC, and we'd better have a digital camera to take some pictures, or we should have a long distance tap measure, various scan antennas, feeders of various lengths and types, backup power supply, WLAN analyze tools, and so on. And except these tools, we should have some softwares. For example, the wireless mount, right, which is for the signal test, and the traffic test software. Here, what we suggest is NetIQ Chariot, and the site survey analyze software, air management survey, and the WLAN packet capture software. The capture software here is a wide package error pack, right? Or you can use some other softwares. After preparing tools, we should get a basic understanding of the WLAN network. At this page is obstacles affecting wireless signal propagation. And actually, we have already introduced this before, right? It's affecting of different obstacles to the wireless signal. For example, the open space, its attenuation is low, right? For example, for the lecture hall, playground, and so on. For the wooden objects, the attenuation is low, right? For the glass, it's low. For human body, it's medium. Water is medium. While, for example, the concrete, its attenuation is high, while the metals attenuation is very high. So during the site survey, we should take these kind of obstacles into consideration, especially when we plan the position where to install the APs. Okay, and next is a basic propagation mode of radio electromagnetic waves. The first is a linear propagation in space, and from this figure you can find actually it's not affected by other obstacles, right? And next is a transmission. The signal is transmitted, right, and it will go through the obstacle. And the third is called reflection, okay? And last is called diffraction. Here are some possible propagation modes of the radio electromagnetic waves. And next is the signal penetration loss estimation. For various building materials, the typical penetration loss value of 2.4 GHz electromagnetic waves are as follows. For the walls of 100 millimeters to 300, the value is 20 to 40 dB. For the floor, it's greater than 30. And for some wooden obstacles, it's from 2 to 15 dB. And for the thick glass, the value is 10 dB. While, except for the effect of different materials, When the penetration loss of AP signals caused by walls and other obstacles is evaluated, it's necessary to consider the incident angle of an AP signals. When the straight line connection between an AP signal and the coverage area is at 45, a 0.5 meter thick wall is equivalent to a 1 meter thick wall. And the incidence angle is 2, the 0.meter thick wall is equivalent to 1 with a thickness exceeding 14 meters. Therefore, to achieve better signal receiving effect, it's recommended that AP signals pass through the wall or ceiling perpendicularly. Okay, and actually it's quite easy to understand. We assume that now this is a wall, okay, and the thickness is, we assume, is 1 meter. So if a signal goes through this wall, the length of this part inside the wall is 1 meter. While if the angle here is 45, so it's obviously to find that the length of this part inside the wall is longer than 1 meter, right? It's longer than 1 meter. So from here, we can know that except the materials, the angle will affect the signals. Okay, this is about the signal penetration loss estimation. And the next is about the radio. Here, what we are going to introduce are two concepts. First is dB. dB is a pure counting unit. It represents the ratio of two values and has no unit. For the power, dB equals to 10 log A divided by B, while for the voltage or current, dB equal to 20 log A divided by B. Here, A and B represent the power values, current values, or voltage values involved in the comparison. And next is dBm. dBm represents the power of radio signals. So it can represent the power. It is decibel value of the actual power relative to 1 milliwatts. Assume that the signal power is X milliwatts. It is represented in dB as follows. P means the power equals to 10 log X. And the X here is signal power. For example, 100 milliwatts is equivalent to 20 dB. Because if the power is 100, so P equals to 10 log 100. And since log 100 equals to 2, so 10 times 2 is 20. And 5 milliwatts is equivalent to 27 dBm. Okay, this is very important, and you should remember how to calculate. Okay. So this is about the site survey preparations. We have introduced some tools, and we have introduced the process of site survey, and we have introduced some basic technical points that you should know during the site survey. And then let's see a question. It says that if the AP transmitting power is 200 milliwatts, then the corresponding dBm value is what? A 20, B 21, C 22, D 23. Actually, the value is not important. What's important is that you should remember how to calculate P equals to 10 log 200. Right? And actually, the result is equivalent to 23. So here we choose D. Okay, that's all for this part.